This is the first of a series of tutorials that will show how Layer 3 addressing provides a mechanism which determines how data travels from one network device to another when using TCP version 4. In this first tutorial, we're prepared to look at the role of the network mask. Now, it's not obvious the role that the network mask plays in ensuring that packets get properly delivered. For this tutorial, it's assumed that you're familiar with binary number system and that you can convert decimal numbers to and from binary format. People use decimal numbers when defining network addresses, but computers only work in binary. In analyzing how network addressing works, we need to look at the decimal number address, but also its binary equivalent. So we'll start our tutorial by discussing a binary operation called the logical AND function. In a later tutorial, we'll show how a network device uses this AND function in conjunction with a network mask to determine whether a packet's destined for the local network or an external network. So let's first look at the logical AND function. And we'll start by looking at binary bits. So the binary number system, we have zeros and ones. If I have two bits and I want to logically AND them together, like this, we perform the AND function and we'll get a result which is either a 0 or a 1. Now, in the AND function, if one bit is a 1 and another bit is a 1, we get a 1 result. And that's the only time we get a 1 result. So any other combination will give us a 0. Two zeros ANDed together will give a 0, and a 1 and 0 ANDed together will give a 0. So this is sometimes called the truth table. Now, how can we use this? Well, let's suppose we want to AND two decimal numbers together. And so we're going to look at an example where we're going to AND the decimal number 6 and the decimal number 5. How do we handle that? Well, the first thing to do is to convert this to binary. And there are a number of ways you can convert to binary. You should know how the binary number system works, but there are also handy dandy little calculators that will do this type of conversion for you. So we have one here that if we want to put in a number 6, we can see down here the binary equivalent. So those can help with large numbers, and if you want to do it quickly, there are a number of binary calculators out there. It's especially useful when you get large numbers. Here, 254, you can see that as an 8-bit binary number, it's all ones except a 0 in the last digit. So we have the number 6, and in binary that is a 1, a 0, a 1, a 1, and a 0. So no ones, a 2 and a 4 make up 6. The binary equivalent for 5 is 105. And when we logically AND these, what we do is we AND corresponding bits. So we'll consider these two bits. And remember I said over here that we only get a 1 out when both inputs, or this is a 1 and this is a 1. That's where the AND comes in. So these two ANDed together would give a 0. These two ANDed together, a 0. These two ANDed together would give a 1. And if we converted that back into decimal, we would get the number 4. Now we're going to look at some properties of AND that are sort of general. If I take any number, I could say take a number x, and I'll use 4 as an example. And if I AND it with a number which has all ones, so 7 is 1, 1, 1, 4 is 1, 0, 0. What you'll get out here, if we do this AND very quickly, you can see we're going to get the number 4 out. And actually, if you have any number x, and if you AND it with any number which has all ones, we're going to get the number x out. So that's an important property of the AND function. Similarly, if I have any number, and if I AND it with zeros, So let's suppose these are 3-bit numbers. So I have 1, 0, 0 for 4, and 0, I can just add a number of zeros here. And you'll notice that when I make a 0, I put a slash through it. That's sort of a programmer's habit, you may see. Anything and it with 0 is just going to give you 0. So another property that's important is if I have any number x and I AND it with 0, I'm going to get 0. Now, how do we use this in a network mask? Well, we'll look at an IP address, for instance, 192.168.85.62. So a machine is given an IP address if it wants to participate on the internet, and there's also a mask. And in a mask, you'll see numbers like, typically like 255, and 0. Now you'll see some other numbers here. A network device actually performs inside a logical AND of those two numbers to determine whether a packet is going to be local or external. And we're going to cover that in another tutorial. This one is just to sort of show us how this logical AND works. Now what's 255? If we went back to our calculator and we put in here 255, we can see that 255 for 8 bits is all 1. So when we have all 1s and we're ANDing it with another number here, we'll get the number back, 192. So 255 AND it with 168 will give us 168. AND it with 85, we'll get 85. When I take a number and AND it with 0, I'm going to get 0. So the result of this operation is this. And we'll show the significance of that in a bit. Now here we've got an example where we have a machine participating in a local network. Now every network is also given an IP address, and so we've assigned the network address 192.168.22.0. This machine has this specific IP address and it has this network mask. Now remember we said that internally the PC is going to do a logical AND of these two when it has a packet that it needs to send out onto the network. Now when it does the logical AND here, it's going to get out 192 because it's ANDing it with 255, which is all 1s, 168.22. This is a 0, so when we logically AND that, we're going to get a 0. And what it's looking for, it's looking to see if this result is equal or not equal to the network address. Because if a packet has to go out and it does this AND on a packet that's destined for somewhere outside in an outside network, if it equals the network address, it's a local packet, and if it doesn't, it's an external packet. And we'll look at what happens when a packet has to be delivered to an external network. Now sometimes network masks can be a little more complicated, so we'll give an example. Where we have a network mask that may be different than the two numbers 255.255, and 0. We could have a number here such as 128. Now when it's not obvious, when we don't have 255 or 0, it's not obvious how these two are going to get ANDed together. We often can't do that right in our head. So we have to take these two numbers and convert them to binary. So yes, we can get the result here, 192.168.22.0. 128.22, but in this part, we'll take 130 and we'll convert that to binary. So our handy little calculator here will show us that for 8 bits we have this number. So we'll write this as 8 bits. And 128, if we used our calculator, we would find is this number. When we AND those together, we AND each corresponding bit as before. We'll get a 1 here and zeros everywhere else. And that number is 128. So this is the logical AND operation that occurs in every network device between network addresses and the network mask. So just to make sure you have a handle on this before we go too much further, there's a little exercise here. So what you should do is try to do these yourself. Pause this video, try to do these yourself, and once you have answers for all these, you can continue. So pause now. So we'll show how to do this last one just in case you didn't get it. 194, the binary calculator is 11000010, and you're ANDing it with 128, which has a 1 in all zeros. So when you AND that together, you're going to get a 1 in the leftmost digit and all zeros, and that number is 128, which we have there. For the next one, 100 is 0110, 0100. So that's the number 100. And 224 has 3 ones and all zeros. So if we look at that and we're ANDing these numbers, we're going to get a 1, a 1, a 0, a 0, 0, 0, 0, 0. We can convert that back to decimal with our little calculator, or we know each digit. This is 2 to the 1, 2 squared. This is the number, or sorry, 2 to the 0 power, which is the number of 1s, the number of 2s, 4, 6, 8. Well, I've got 132 and 164. So I know this number is 96, which is what we have here. So if you didn't get those, review that so you know how the logical AND works, and in the next tutorial we'll show you how this works with the net mask.